Hey everyone, welcome. How's it going? Welcome to episode 106. Glad to have you all. Really excited to be back as always. If you're just joining us, feel free to say hello in the chat. If you want to say where you're tuning in from too, that's always welcome. Let's see who we've got joining us so far. Alex, how's it going? Welcome. Waleed, glad to have you back. Looks like we've got Duffy with us today, which will be great. Hey Duffy. I feel like I haven't seen you all week. You must have been really busy. Martin from the Netherlands. Welcome, Martin. Glad to have you here. Rodolfo, ready to learn. Good. Happy Friday as well. Maddie, glad to have you back. I think this issue and recommendation came from you, Maddie. So thanks for that inside of GitHub. We really appreciate it. Surish, we got you from Hamburg. Welcome. Tim, in from San Francisco. Welcome, Tim. Glad to have you. ABC, welcome back. Always happy to have you, giving us some good insight. Nick, yep, Nick knows that my work setup is in my closet because it's quiet in here and very easy to focus. So, thanks, Nick. Welcome, glad to have you, man. Grigor from Moldova, awesome. Welcome, glad to have you. Steve, hey, how you doing? We're gonna be I think we're going to be using some Contour today, Steve. So for those of you who don't know, Steve works on the Contour project at VMware. Used to be on my team as well, but now he's focused on engineering stuff. So welcome back, Steve. Antoine from Paris. Awesome. Welcome. Mozufer from Dubai. Welcome. Glad to have you. All right, everyone. Welcome. So as people are still filtering in, let's take a little bit of time and go over the news. What do you say? So, I see a lot of familiar faces, but for those of you who maybe aren't as familiar with TGIK, one of our starting points is to talk about what's going on in Kubernetes this week. So, we're going to kind of kick that off here. George, as always, has filled us in with some really good details to kind of go over. So, let's start off with the weekend review and the core. So, 1.18, we're getting closer and closer. There are 50 enhancements that are being tracked. I actually want to show you all some of the ones that I'm most excited about. And if you're not aware of where the enhancements spreadsheet is, you might find that pretty interesting. Those of you who are working on core Kubernetes or related Kubernetes projects, do note that the freeze is coming up Thursday, March 5th. All right. And the plan thus far, I'm guessing, is to have it rolled out, 1.18 rolled out Tuesday, March 24th. So there's some details we have in our HackMD around patch release updates as well. But let's take a moment to talk about some of the 1.18 things that are going on here. So, and I will just click on this. Cool. So inside of our HackMD, which it looks like George may have just put the notes link in chat, so feel free to check that out too. There is a link in here, which is the enhancements tracking spreadsheet, which is a pretty cool way to see what exactly is going on for the 1.18 release. It's got some status information. I like this enhancements tab because I can tell whether it's something that is being graduated or if it's something that's kind of a net new feature and all that good stuff. So looks like there's lots and lots of cool support for things coming in, a lot of new updates and so on. So do check this out if you're curious what 1.18 is going to have inside of it. I pulled some of my favorites out. I figured I'd share them with you all if you have not dug too deep. So one thing that's going to be introduced in alpha in 1.18 coming from SIG CLI is an events action that you can run using kubectl. So some of you might know that using kubectl, in fact, I can probably just show you real quick as long as my cluster didn't die on me. You can do kubectl get events, and it will get events for the namespace that you're currently looking at, which is cool, works pretty well. But there's definitely some limitations, and I think as people have been building more and more extensions for Kubernetes and kind of features around Kubernetes, they've been relying on using the events API a little bit more, which allows them to kind of give these more kind of discrete actions that happen rather than just pumping everything through logs. So from the first look, and I've by no means tested it out, it looks like some of their intentions are to provide streaming of events through this command, more fancy filter type capability on top of it, being able to watch particular objects based on events. So it's looking pretty cool. I think this will be a really exciting one, especially for those of us who get in kind of the debugging kind of workflow, and events oftentimes have the information we need, but we're trying to figure out where to get to the events, how to filter through all the massive sets of events that might be happening in a namespace, and so on. So this is kind of a cool one to check out in 118. And then another one, speaking of debug, those of you who spend a lot of time debugging like myself, I feel like that's all I do nowadays. There is a new debug capability being added to kubectl as well, it appears. So at first glance of this one, and I actually didn't know this one until today, so thanks, George, for posting that. It looks like it's going to make use of the ephemeral containers, which is kind of a cool concept where inside of your pod, in theory, you'd be able to set up an ephemeral container inside of that pod, which could potentially have some like debugging tools and things that would allow you to better debug what's going on with your app. And so what this could help us with is, a lot of us use kind of really minimal images for our apps nowadays, especially those of us who are lucky enough to compile into like statically linked binaries. We'll use Scratch, which is basically a nothing image for the most part, where we just put our static binary in to run. Some of us use DistroList from Google, which is pretty close to Scratch, but will also give us some things that are really nice, like the ability to set a non-root user by default without having to do any trickery. So, when we have these really minimal pods running, the ability to leverage ephemeral containers to attach some type of debugging tool set in that pod, which, as you know, containers in a pod share namespaces, right? So process namespaces, network namespaces, all that good stuff. So, like I said, I haven't dug too deep into this, but kind of as a description implies, a lot of times we're doing like exec and port forwards and all kinds of stuff. Maybe this could give us a really clean way to kind of get inside how that pod's thinking and see what's going on at the container level. So pretty cool, pretty excited about it. And then one more I was going to share with you, which I thought was pretty interesting as well. I need to keep up with what's going on in Kubernetes. I feel like I just wait till the release comes out and then get up to speed, but all this is so interesting. There is a notion of sidecar containers that are going into alpha in 118. At least I think that's what the release said, 118 alpha. And sidecar is pretty interesting because those of you who have set up containers, I'm seeing if there's like this is a good example. Those of you who have set up containers in a pod, going off our last convos, a pod can have many containers, right? And historically, containers were all kind of treated as the same citizen, right? I think the notion being, you have just kind of these like init processes that you can set. So you've got the kind of init commands and init things that you can do, but then you've just got all the containers. But oftentimes we refer to containers as like sidecars conceptually, even though from a Kubernetes standpoint, there's no true notion of sidecar, right? So let me give you a more concrete example. Let's say you're running a service mesh, right? And your sidecar in the service mesh for most of your workloads is likely to be something like Envoy, right? So by having this notion of setting up a sidecar container, it's going to actually change how some of the lifecycle pieces work. So when you kind of shut down and start up. So trying to see if I could find the description here where it talks about the startup process. Let's see. It had a pretty good description of it. Okay, yeah, actually this was it right here. So init containers start, init containers finish, and then our sidecars start, right? Sidecars become ready, and then the containers themselves start. So when we have those proxies and things that need to kind of start up before the app does and all that kind of stuff, I know the order of operations, I've done some really gross things, frankly, in Kubernetes to make sure things kind of paired up well. And I think this will give us a little bit of a cleaner conception of like, this is my primary app pod. And here's some of the sidecar pods, such as the ones that, or sorry, I shouldn't be saying pods, but sidecar containers, such as logging, proxying, and so on. That's going to make my workload function well in this environment. So pretty cool. Yeah, so just wanted to share those three with you. The introduction of sidecar containers, the kubectl debug command, and the kubectl events command. So per our show notes, if you haven't checked those out, get a full list of all that's going on in 118 so you're ready when it comes out with some of the new features. Cool. All right, so who do we got? Alex. So Alex is on my team at VMware. Alex, great to see you, man. Welcome, welcome. Timmy, also in my group as well. Yeah, you're right, Timmy. Where is my hat? That's a great question. Unfortunately, I don't know, but you're right. I do feel a little weird without it. Especially now that you pointed it out. Thanks, Tim. So cool. All right. And Waleed, keep up with the Cloud Native Podlets last episode. Yep. Very cool. I'm glad you've checked out the Podlets podcast, Waleed. That's a new podcast we're trying to put out weekly about Cloud Native stuff. Stefan, welcome. Glad to have you. All right, so let's get a little bit further, and then we'll get into some goodness around Flagger. So a couple ecosystem updates. These are like blog posts and interesting news things that we thought you should check out. Learn Kubernetes.io, learnkates.io has published a blog post about one of the most common questions that I have to talk to my customers about, which is how big should your clusters be, right? Or maybe better put, as they say, how many clusters should you have? And this is a really, really complicated problem for those of you who have architected Kubernetes clusters in the past, right? You've got this massive spectrum of potentially like even single tenant use cases, which is what the bottom row is attempting to imply, which is like, we have an app, we're going to spin up a Kubernetes cluster for that app, or maybe, a couple of microservices that make up the app, and it's going to run on this cluster. And then on the other side of the spectrum, we have the large shared clusters, which I think when Kubernetes first became popular, at least this was my experience, is that everyone was shooting for this large shared cluster model, right? And I think a lot of that, and I don't really know the inner workings of Borg, so don't take my word for this, but like I think a lot of people are trying to mimic some of the larger systems they had read about in various white papers, things like Borg and otherwise, where there was seemingly like this massive sea of compute that people just scheduled on top of. So a lot of people and a lot of companies I work with are trying to set up one Kubernetes cluster and then run all their workloads across that massive cluster, right? So they can treat it all as like this conceptual sea of compute, and there's no segregation between clusters. My experience, and I think this does a pretty good job of kind of talking about it, is a lot of folks who started there realize that that's really hard to do. And at minimum, they split up their different environments into different clusters, right? So dev, prod, test, QA, whatever million qualifiers they have for their different environments, they'd split those up at least to get some segregation there. And then as time went on, I'd argue that even more and more kind of splitting up of clusters happened with a lot of the people that I worked with, where they were running more smaller clusters. And I think it was kind of twofold. One, it was just experience with Kubernetes and how it can be hard to run one massive large cluster. But two, also like lifecycle management of Kubernetes is getting easier over time. So as we're talking more about federation and service routing capabilities, you probably all are very aware of Cluster API. When we actualize that into something that's really stable, the beauty of just making an API request and clusters showing up, that can really enable us to have, more multi-cluster facilities without as much overhead of managing each individual cluster. But anyways, that's my soapbox. I would check this article out. I read through it very, very quickly, and I think they bring up some really great points. They go through like one large shared cluster, and like everything, it's just a list of trade-offs, right? It's what trade-offs are right for you. They talk about how the administration would be centralized. You have more efficient resource usage. You're not replicating your control plane as many times. They talk about some of the big ones that I always run into, like achieving true security isolation in a Kubernetes cluster. So when you have like a multi-tenant cluster, like imagine that you're a company that's hosting customers on a shared cluster. The tenancy constraints that you need to put in place and the isolation you need to put in place are pretty serious in that case. They're a lot more serious than they'd be if like, Duffy and I are just running our apps side by side in some cluster, and to some degree we sort of trust each other, right? It can be really tough to have security isolation in these larger clusters. And then they go over the trade-offs for kind of the single-use small clusters. So this would be almost like a cluster per app. And then, that was in section 3 here, cluster per app. And then they've got the cluster per environment model. So, like everything, this is a spectrum where you choose where to land on it based on your trade-offs and your environment. But nonetheless, it's really detailed. Check it out. They did an awesome job. So great work, Daniel, if you ever see this. It's a really good write-up. Cool. So another really great one. I feel like this has surfaced a couple times now. CPU limits and aggressive throttling in Kubernetes. Excuse me. Faiz, hopefully I'm saying it somewhat correctly, talks a little bit about some of the underpinnings of how resource allocations work in Kubernetes. So not only might this give you a consideration depending on how you've got your cluster set up for CPU throttling, but it talks about some of the kind of in the weeds things that we don't always know about. One of the things in Kubernetes that I think a lot of us are aware of is you have the ability to request a certain amount of CPU, and you have the ability to limit a certain amount of CPU. And sometimes it's simplified and we say like, okay, well, requests are for like the Kubernetes scheduler to figure out where to put something and how much it should conceptually carve out. And then the limit is like enforced at the runtime level. This will actually like be throttled at a certain level. And if your CPU hits that, we'll throttle it down. Now, in actuality, it's a little bit different than that. At runtime, at least for CPU, both of these things do get respected. As an example, let's see if they've got them here. CPU shares is what I'm looking for. So the CPU, let's see if he mentioned the CFS anywhere. Yeah, there we go. So inside of requests, it's going to go in and it's going to provide kind of like this certain amount of shares that you get inside of the runtime, right? And then with limits, it's going to use this thing called a completely fair scheduler to actually throttle you. So the notion being like, if your node comes under contention, you could have a higher limit than what you requested. And if that CPU is available, it's actually going to let the CPU go higher, at least up to that limit bound, right? But if the host comes under contention, it'll start kind of throttling down the CPU. And what this article goes over is basically the implications of that, the calculation of the CPU limits themselves, and how kind of those get calculated. So it talks about, unlike CPU shares, this quota is based on a time period and how that time period calculation happens. So check this out. It's super interesting. It shows how under resource contention, the error rates can actually go up in the presence of CPU limits. So in this article, and I don't know if they call it out directly, but I believe the too long didn't read is they modified whether the kubelet was even respecting CPU limits at all. So it's really, really cool. There's another article that's very similar to this one. If you want to dive deeper into it, it was done by Zalando. I'll look it up after this video and put it in the show notes. They actually did a presentation where they talk a little bit about the implications they found from running CPU limits and how it impacts the completely fair scheduler and all that good stuff. So really cool. Check it out. Pretty in the weeds, but good information to know. Cool. And then one more that I'll just mention, and then we'll get right into it, is on deploying Spark to Kubernetes. So a guide was released from developer.sh on putting Spark on Kube, which a lot of folks want to do, but like some stateful Java apps, it can be a little bit challenging to know how to set it up correctly, or I guess just Java apps in general sometimes are a little bit more complicated than those of us that live in a static binary world. So check this article out if you're looking to run Spark. They have some cool gotchas and instructions on how to set it up and run it. So pretty cool stuff. Cool. All right, I'm gonna check chat one more time and then we'll get right into it. Maddie, anyone happen to know if pod startup shutdown ordering ever got implemented? I'm not sure offhand, Maddie. That's a good question. Not that I have seen at least, but it might be a feature that's out there and I'm just not aware. Cool. All right, all. So we're going to talk a little bit about Flagger now. So those of you who are in chat, I know I talked to some of the folks in the Weaveworks Slack. Do we have any Flagger maintainers or Weaveworks employees in the chat who are with us today? If so, feel free to say hey. All right, let me just pull over my Flagger. There we go. Cool. All right, so Flagger. Let's talk about it a little bit. And again, if we have any people who are on the project or work on the project, feel free to say hey in the chat. We'd love to identify you and say thanks for showing up if you did. So Flagger is, let me just pull up the website here real quick. Flagger. Awesome, Stefan. Oh yeah, I should have recognized your name. Thanks for joining us, Stefan. So those in the chat, Stefan's here, who's a Flagger maintainer. So he'll be helping us out and answering questions as they come up. Thanks for joining us today. All right. Just getting my brain together as we switch from the news to Flagger itself. So this is probably something that most of you who have run Flagger in the past, or sorry, those of you who have run Kubernetes in the past probably know that one of the kind of complex things that we want to do is have some more intricate rollout strategies. Thinking about how we can slowly bring a new service or an updated service even into production. And there's a couple things that we oftentimes consider here, like the very kind of naive way that we've tried to do it in Kubernetes before, as many of us know, is we'd start off with the idea of a replica set, right, which is probably backed by a deployment. And then we'd have a service over top of that, Kubernetes 101 stuff. Traffic comes in, hits through the service, hits on the pod. And then oftentimes what we'd do is we'd introduce a version 2 of that app behind the same service, right? And then since, at least by default, those of you who are just using IP tables to do, kube proxy-based service routing, you probably know that, in the absence of an ingress controller or anything, what's typically going to happen is you're going to round robin to those pods. And slowly over time, you might increase the pod count on version 2. And then if things go well, you decrease the pod count on version A. Now, that very simplified model is great. However, there's obviously a lot more complexity that comes with doing this in the real world, right? Because, reality is we want to slowly roll traffic based on maybe some type of percentage, right? We may want to do some type of validation logic to see if things are working correctly. And maybe if we can get this fancy, even roll back should things blow up on us and fail, right? So Flagger has a bunch of different options for doing progressive delivery. 3 of the most common, which we run into all the time in the field at least, are Canary, which usually is kind of introducing a new workload, slowly bringing traffic over to it, hopefully doing some type of validation, right? Canary in the coal mine is kind of like where that notion comes from. We've got A/B testing, which can be especially helpful for like UI designers and people who want to, say, introduce a certain version of something to a certain geo, so that they can see what the results are over time and determine whether that's appropriate before they switch over. And then blue-green, which is a little bit more like kind of a cutoff where we have, green, where we have green up with the new version, and we're effectively able to shift traffic over to it. But if something goes wrong, the ability to kind of roll back the old version still around as kind of a warm version of the app, if you will, not completely killed. So what's interesting about Flagger is it can fit into, the larger kind of GitOps mentality, which I think a lot of the community is starting to move more and more towards, where we check something into Git, and something inside of the cluster perhaps in certain implementations realize that the cluster state needs to be updated based on that change and does the things that are needed to make it run well, right? Now that's a super simplified, naive explanation for GitOps, but part of that equation of bringing all these things together is to use something like Flagger to actually facilitate the rollout aspect of the app. So we did some past TGIKs as well. If you haven't seen them, I think we've done Flux and Argo, right? Someone correct me in chat if I'm wrong there, but I think we've done TGIKs on both of those. And we are today just going to focus on the Flagger aspect, right? Which is this rollout piece. So let's get right into it. Inside of the docs, we are going to be taking a look at Contour in particular, but I should mention, and I think this is kind of one of the really cool things about how Flagger is set up, is this utility that is hopefully going to help us facilitate Canary, blue-green, and so on, plugs into a variety of service routing solutions. And saying service routing solutions somewhat generically there, right? The idea being you could have a full mesh you want to do this thing with. So maybe you're using Istio and you want to kind of automate some of the validation and rollout strategies. Flagger can plug into that. Linkerd, Nginx, Glue, so on. And today, selfishly, because I know Contour pretty well, so I'm not going to try to boil the ocean here with deploying Istio on top of all of that, but we're going to use Contour as an example. So Flagger is going to get deployed, and with Contour running, ideally, we're going to be able to shift traffic into different services or different deployments, really, on the basis of what Flagger has us kind of roll out. So first things first, everyone, let's go ahead and deploy Contour. I have a feeling we won't get super far without Contour. So inside of manifests, I've got a Contour YAML that I'm going to show you all. And inside of this contour YAML, let's make the text maybe just a tiny bit smaller for you all. Might make it a little bit readable. Okay, so contour is nothing special. I actually looked at the Flagger docs a little bit earlier and checked out the contour version that they were using. The only difference is with contour, maybe I should actually just give a quick intro to contour. So contour is an ingress controller. It's one that we've been working on since a lot of my group was at Heptio, and now at VMware it's been taken on. It's a completely open source project, CNCF. We have a lot of different contributors on Contour, and the idea with Contour is we use Envoy as the proxy, okay, and Envoy or reverse proxy, load balancer more or less, and we have a controller called Contour that, based on ingress resources and special resources that we call HTTP proxy, I believe is now what the API is called. We'll check that out today. It's going to program Contour to shift. It's going to program Envoy to route the traffic appropriately to different pods and so on, okay? So effectively what we're looking at here is this is the Envoy part of the puzzle. And how I've got Envoy set up is I'm just going to link it to the host ports on my machines, which I'll show you in a moment. So I'm not going to use like load balancers or anything like that on top of it. We're just going to route directly into the machines in this use case. So let's go ahead and get Contour deployed. We'll open up another buffer here real quick and do a kubectl get pods for the namespace project Contour. Looks good. All right, so manifest contour.yaml, and there we go. So Contour is deploying, and you can see the Envoy. I believe I've got Envoy running as a daemon set here, so it should run on every node if all goes well. Cool. All right, just checking chat while it's starting out. Okay, cool. Flusk and Argo. Cool. Thanks for posting those episodes, Waleed. Sounds good. Cool. Oh, it has Argo changed a lot since the last TGIK. I haven't been tracking it super closely, ABC. We probably should do a second look, kind of like what we did with Cilium, if that would interest you all. Kind of another look at Argo now that stuff has changed. I guess, honestly, we could probably take our whole backlog and do a second look at this point, because stuff moves so fast. It's hard to keep up with all the changes. Cool. Just more context there. ABC makes sense. Steve. Yep, so to Steve's clarification. So the idea here is going to be that we're going to be running Contour and using a CRD called HTTP proxy, which gives us a bunch of capabilities beyond just what the default ingress API is. But it is also going to support, or also does support, just ingress resources. So Contour works natively with the core Kubernetes API as well, should you choose to use that. Stefan, what version am I using? Let's just double check. It should be pretty darn new, so give me a shout out if I'm actively shooting myself in the foot here. Let's check out the image version. Image. I'm using latest, which is probably 1.2 then. So give me a shout if the new version would have any issues. It's definitely 1.0. I saw in your docs you need at least 1.0. Cool. All right, so we've got Contour up. Let's do a couple more deployments, and I'll see if there's more questions to answer in chat here. Okay. So Contour's up, and I've pulled up their the Flagger documentation for Contour Canary deployments. And let's see what we got going on. So they recommend deploying Contour, which I just did. So Stefan, this is what I was reading: Contour 1.0 or newer. Cool. You haven't tried 1.2. Okay, well, we'll know if things blow up. We can always roll back to 1.0 or 1.1. No biggie. All right, so what's the first thing we got going on here? So install Flagger using Customize. Okay, so let's get this deployed, and we'll take a little bit of a look at what it creates and kind of what some of the pieces are. Maybe Stefan can even help us understand how these pieces fit together here. So I did notice that this was a GitHub page, so I went ahead and just pulled this down before the show just to make sure I have the manifest. So per the docs, it wants me to do a kubectl apply with -k for customize, and then we're going to go to the Contour directory, which I'm guessing has Flagger inside of it. So let's apply -k, and we will do the, let's see, where did I put this in again? I think it was it customize? It was manifest. What do we got? Customize. Yep. Manifest, customize, Contour. Okay. And oops. what did I mess up? Kubectl apply -K manifest customize contour. Huh, what did I blow up here? Let's see. So we've got unknown shorthand flag -K. I think it should take -K, right? Because wouldn't that be customized? I think I did -K, right? What am I losing my mind here? So kubectl, we will apply -K, right? And we'll do the manifest customize contour, which has these inside of it. Huh. Unknown shorthand flag -K. What version of kubectl am I using? Kubectl version, I would think. Oh, looks like -K was removed. Interesting. So my kubectl version, my client version is 113. Ah, how did that happen? I've used customize before, but I must have messed something up. That's super interesting. Okay, so let's get a new version of kubectl here real quick. What do you say? So yeah, -K is only valid in 14 plus. So let me just pull something up here, and we'll try to download it, I suppose. So okay, so I'll bring up my browser here in just a second. Good catch, everyone. I'm trying to think, though, because I was playing around with Customize the other week, and I just can't figure out how I got an old version of it. Nonetheless, let's see if this works. So we're going to pull it from the Arch repository in my case. So I'll do a pacman rs, maybe just r kubectl, and we will sudo that. Okay. Oh, I put it in there manually. Okay, I must have done something really weird then. So I wonder if it's in my user local bin as kubectl. Nope. Let's see where I've got it here. It's always good when the first thing that's blowing up is your kubectl. Okay, let's do it live here. Let's go ahead and delete kubectl and see what's going on. So user bin kubectl. Cool. All right, and then I will just go ahead and cheat here and quickly go to this directory, grab this kubectl bin from the Arch repository, and then we will try to install it. So, okay. All right, so while that's installing, let's check out chat and see what we got going on. All right. Yeah, ABC, your question was how do people manage cluster deployments, cluster API and such? You know, I think there's a lot of variance in that today, to be super honest with you. You know, I've helped customers manage clusters in a lot of different ways. Some use purely homegrown systems. Some use, you know, simply pipelines and things that try to keep customers or clusters up to date. You know, that being said, I think with cluster API and with the notion of like a supervisor cluster that could theoretically manage many clusters, it could simplify and or unify cluster management. But even like a lot of vendors, you know, who make products that you theoretically buy for X number of dollars, they kind of monetize off this deficiency, in my opinion, to some degree, right? I mean, even at VMware, we're trying to make that multi-cluster management a lot easier. So hopefully that answers a little bit, but I've personally found a lot of variance in that. It's a great question. Okay, let's see what we got here, everyone. So did we fix the version, kubectl version? Our client version is 117. Okay, so are we going to be able to deploy? You know, just a little, the demo gods and the presenting gods got to make sure that we don't have this too easy. Okay, we can't just get away with it working the first time. So if we do kubectl and we apply -K, we will do in this case manifest. Oops, I should be in the right directory again. So let's go back to the TGIK folder, episodes 106. Okay, so let's try that apply one more time with the K. Much better, huh? Okay, so see, I was even playing with it the other day. So it's got some of the CRDs and stuff. So I have no idea what I would have done to blow that up. Nonetheless, we've got Flagger. Congratulations, everyone. So we're going to be able to actually try this out. All right, so what did this create for us exactly? So we've got a Flagger pod. Maybe we can start by just quickly looking at that. So if we get the, the pod for the namespace, what am I in? Project contour. We will print that out as a YAML file, and we're going to grab the pod for Flagger. Let's start there. Note also that Flagger deployed a Prometheus instance for us too. We'll try to dig into that a little bit later as well. So, okay, good deal. All right, so we've got this pod named Flagger. Inside of here, it looks like some of the flags that got passed. So this is probably where the provider, that kind of plugin detail gets put in. Like I was mentioning, like I would think this could be Istio or Glue or whatever. It does look like it's got some built-in Slack notification stuff as well. So that's kind of cool. Liveness probes, pretty standard stuff. Readiness probes, limits. Okay, so it seems like for the most part, I'm not seeing anything too crazy in here. It looks like as far as the Flagger application goes, it is mostly concerned about what mesh is it integrating with, and then where can it find the metrics server at. So that all looks pretty good. All right, so let's see if we can bootstrap some different tests. Now, one thing actually, let's check something out here, everyone. One thing I think it did make, let's see if I've got kubectl get, I think it was called Canary. Okay, so Canary, let's see if we've got any. I guess we probably don't have any yet. It's probably going to have me put those in a little bit later. Canary API. Okay, jumping ahead of myself. So let's get some of their recommended test data in here real quick. So we'll create a namespace for test. Kubectl create namespace test. Looks good. Okay, and then it wants us to install a load balancing service to generate traffic during the Canary analysis. Okay, so this will probably be a load tester of sorts. So let's go ahead and apply that as well. Okay, so we will do our apply. This time, instead of customize contour, we'll do customize tester, which created service Flagger load tester, deployment Flagger load tester as well. Looks good to me. Okay, so let's see if we can find these real quick. They are not inside of project contour. So get pods, all namespaces. Oh, test namespace, duh. We just created that test namespace. So we've got the Flagger load tester inside of here as well, which seems to make sense. Okay. All right, and then they have a example app it looks like we're going to deploy, and then maybe we can get some of these things interacting. So we're going to deploy a pod info image, which is probably just going to print out data about the running pod. So let's try that now as well, and then we should be able to start kind of trying some of these bits out. So we will customize apply again, and we will do manifests, customize pod info. Looks good. And by the way, every manifest I apply today, I will put in the repo for TGIK episode 106. So if for any reason you're trying this out while watching this video, be sure to check out the GitHub page. These manifests will be in here in their current snapshotted date. So if you're watching this in the future, you may want to check for newer manifests nonetheless. Okay, so we've got a pod info created. That seems fine with me. So let's see where pod info got put. What do you say? So we'll check out test. It looks like, okay, pod info is running in test. So let's bring the text size just a bit smaller here. Okay, so we'll do cool kubectl get pods namespace test. All right, so here are our pod info pods right now. So just to make sure we know what's going on, let's also check out the services. So we've got a load tester service right now. And then maybe we can also see if there's any ingress or HTTP proxy objects in here. So, okay, good. Doesn't look like anything yet. So looking at the service pod ingress, so far it seems like all we've deployed are the pod info deployments, which is probably going to be our test app, and then the Flagger load balancer, which I'm guessing will help us generate load on these as well. So those seem to look okay to me. I'm guessing it looks all right to you all as well. All right, so this is probably the most important one. So what we're going to do now is we're going to bring in the sample Canary object they have in here, and we'll take a bit of a closer look at this API. And maybe, Stefan, you can help out if I say anything terribly wrong. Feel free to correct me. But let's take a look at probably the crux of this all, which is the Canary API. So canary.yaml. All right. Just make sure my paste won't mess me up. Okay. Cool. So we have got a kind of canary. So this is apparently the API that Flagger is going to introduce for us. Given that Canary is attaching to pod info, I'm guessing we create one of these Canary objects for every type of application, which would make sense. Okay. And then we've got, oh, it's well documented. Good. Okay. So we've got the deployment ref. So clearly we're going to be pointing at the pod info names. So out of curiosity, Stefan, you might know off the top of your head, does this allow like label based selection, or is it strictly, going off of names for right now? Like, could you use arbitrary labels here for your deployment reference? I'm trying to think how much complexity that would add, but nonetheless, autoscaler ref. Okay, so a horizontal pod autoscaler to scale the instances of pod info up and down. So we actually did a TGIK somewhat recently on HPA. Same ref. Okay, cool. Got it. Makes sense, Stefan. Same ref as HPA. So service. Okay. So the service port of where we're talking, I'm guessing, and then the container port, which also makes sense. Cool. It's got a contour retry policy inside of here as well. So I'm wondering if that's got something to do with the test. Maybe we'll come back to that. And let's look at the Canary analysis first. So analysis timing and KPIs. Okay, so this is probably where some of the gold is, right? We've got an interval that is probably a timer on how often we do something based on the Canary's configuration, I'm guessing. Okay, this is great. So max number of failed metric checks before rollback. And then the max traffic percentage routed to Canary. So it looks like our max in this case will go up to 50% at the very most, shifting over to a new version of pod info while the tests are going on. And then the step weight. Okay, this is cool. So if I'm reading this correct, and again, keep me honest here, Stefan, if I say anything silly, but we're going to go up by 5 percentages. I'm guessing that's going to be on a 30-second interval. Keep me honest there. And then our max that we'll max out on when doing the Canary analysis will be 50%. And then I'm guessing if all goes well at some juncture, we should completely cut over if it would automate it like that. So inside of here, we've got some metrics. We've got a request success rate, threshold, request duration. Okay. So probably milliseconds, 500 milliseconds, intervals 30. Okay, looks good. And then some webhooks. Okay, so this is probably, okay, great. This is where this tester is going to come in. So let's see here, webhooks, acceptance tester. So this is going to kick off, I'm guessing, immediately. I can't tell if this is going to be something that happens last. Oh, no, this is pre-rollout. Should have read it right there. So pre-rollout, we're going to do the acceptance test. That makes sense. And then we have a webhook that we can put for load test. So this is going to kick off a load test to our application. In fact, I did read ahead in the docs earlier today, and I think I need to put one of my own custom domains in here just to make sure that we can make it work and I don't have to mess with I won't have to mess with my Etsy host file all day. So I did actually set up a DNS record for today. Let's just make sure it's working. I probably should have double checked. So it was app.jkates.com. And this is pointing to my host, which is where the Envoy proxies are running. So this should be good. It's a public record that's pointing to a private IP address. So hopefully that'll work. Let's go ahead and replace that here. So cool. We'll get back here. Oops. I did not mean to do that. So do I still have my Canary? Oops. Okay. Canary.yaml. Hit the wrong key there, everyone. Let me just bring over this file one more time. Cool. All right. Actually, I didn't even look at what I did. I probably just discontinued the tmux session, so I probably could have reattached. So let me call this c.yaml here. Okay, and then edit c.yaml. There we go. Okay, cool. So what I was trying to do here before I hit whatever key I hit is to set this to app.jkates.com, which will be my particular IP address. So I'm curious. I don't know, Stefan, if you know. I mean, I'm sure you probably do know off the top of your head. What is this? What's this HTTP piece relate to? I'm curious if that will break on me if I'm running this locally. I'm not really sure, but just to double check on that. Otherwise, I think we're looking okay. So let's try to deploy this canary. So we will kubectl, apply canary.yaml. Oops, not that one, Josh. Come on. Now my flags are all messed up. So delete. There we go. Okay, kubectl, apply. This will be c.yaml. Okay. I think the bane of my existence this episode is going to be that F and K flag. Okay, now we should probably be good. So if we do a kubectl get canary for the test namespace, cool. So we've got one that says initializing. Name is pod info. We've got probably a current wait. And then last transition time, I'm guessing, is the last time it tried to move between two different versions. So hopefully that'll be okay. All right, all. So we've got a canary. We've got the load testing tool that we'll probably use soon in there as well. We've also got the deployment of pod test and contour deployed as well. So I think we should be looking pretty good. Now, this will be our first exposure to Contour's HTTP proxy. So before we try doing anything crazy with an update, I'm going to take their sample HTTP proxy and we will create that in the cluster. And let's just start off by making sure that we can actually route traffic, because that seems like a pretty important detail here. So I'm going to copy that over. Okay, and we'll call this HTTP proxy.yaml. Okay, and then we'll set paste. All right, so we've got pod info ingress. Our virtual host, as we talked about, is going to be app.jkates.com. Okay, so that looks pretty good. And pod info tests, that all seems to check out pretty well. All right, cool. Got that. So we will apply the HTTP proxy YAML file. All right, good deal. So now if we do a kubectl get HTTP proxy inside of the namespace test, we now see that there is, there was a one from before. I thought I checked for that. Oh, nonetheless, okay, this will be our fully qualified domain one. So again, those of you somewhat new to Contour, just know that this CRD is basically our own ingress API, if you will, that provides extension capabilities. But if you're using Contour, you have the choice. Do you need or like those extra features? If so, you can use this HTTP proxy resource. Otherwise, you could just drop an ingress in here and it would work fine. And actually, Flagger, I guess, is a great example of this, because I'm guessing, not that we've gotten that far, that Flagger is going to adjust percentages of weight over time, or at least something like that. And by using this HTTP proxy CRD, it's actually going to have those knobs available to it, more so than it would have inside of a standard ingress API. So seems to be good. Okay, let's just, before we try our first Canary rollout, let's see if we can even access this page real quick, because I have a feeling that will be our first point of contention. So we know that we've got this ingress resource here. So let's start off with just kind of reverse engineering how some of this would work, okay? Which is usually where I start when I do this kind of stuff, just to make sure I've got all my bases covered. So first things first, if we were to curl, okay, first things first, if we ns lookup, right, app.jkates.io, do we get, .io.com, do we get the right IP address, which it seems to be okay. So this is the server IP address that one of my workers is running on. And I just know that because this is running on a server in the other room, and that's all fine and dandy. So that's good. Now, if we curl app.jkates.com, and then we do a v4, I guess, we are getting sent to pod info. So that's also good news. I'll make that a little bit smaller so it's easy to read. But you can see here that the server that it's receiving it is Envoy. So that's a good sanity check. Even if we weren't getting something back, perhaps we could see, are we hitting Envoy? And now we seem to be getting the pod info container, which is great. So notice the version is 3.1.0, at least right now. So that all looks good. We've got the the cuddle clap logo, which since that worked, I feel like we deserve getting to look at that really quickly. So, this will be our mascot for success throughout today. That looks good. And just some details about the Linux host. Now, all right, so we're routing. That's a good thing, right? So let's see if we can get an update deployed. And I'll just check the messaging real quick. Waleed, you saw the bracket. Yeah, thanks for that. I think I got that one sorted. Can use any combination of Prometheus metrics to control the way traffic shifts from A to B. That's what I'm wondering too, Maddie. Stefan probably knows offhand, but I'm thinking like some really cool custom validation logic based on things that you can scrape up through Prometheus. That would be really cool. Okay, I see Stefan. So Flagger added that initial pod info resource. So that was that big Flagger deploy that I did, which would make sense why it didn't show up originally. Okay, so let's see if we can actually do a promotion here. All right, so Flagger implements the control loop that gradually shifts traffic to the Canary while measuring the key performance indicators. Okay, so these are the KPIs that we'll be looking at, and we saw some of those, I think, in the Canary manifest. So as we do this, we'll try to see if we can figure out what's happening behind the scenes here, right? So traffic comes in, the controller is waiting in phase 2. Actually, this is perfect for us, right? Because we know the increment is 5%. So 5% gets shot to V2. And then it increases the quantity of apps, it would seem, maybe through HPA. And over time, it will eventually max out at 50%, which is going to mean that V2 should be getting 50% of the traffic, I believe. I'm guessing in step 5, if all goes well, this represents you got to 50, everything was good, we promoted you fully to 100. And then I'm guessing these are just extra instances that get killed off if it's deployed too many up front, perhaps. So we've got a really easy trigger that we can do here, which is the pod info trigger. But I want to make sure that we can see what's going on, right? So underneath this, ooh, look, wouldn't it be nice if we had that events command right now that we were talking about earlier? So using kubectl describe, we can get the events for this particular test. Okay, so here's what we'll do, everyone. We'll set up a watch. Let's see, describe's pretty loud. We'll either set up a watch for events or describe, and we'll see if we can watch this progress here. And then we'll trigger this and see what impact it makes. So the only thing I'm actually not sure of, and we'll just try it and see if we can figure it out, is it going to trigger that traffic, that little traffic pod and send stuff to validate it? Or, what's going to be its signal that things are going well is what I'm wondering. And if we go back to our Canary deployment from earlier, it seems like it's going to be contingent on this, right? The, where was it at? The webhook, right? So I'm thinking it's going to call this in the Flagger load tester. And then if it gets 200s, I'm guessing it's going to progress on. So let's see if we can tell what's going on there. So give it a shot. All right, so first things first, everyone, let's get a little watch in place here. So first thing, kubectl, namespace is test. We'll do a describe for Canary pod info. Okay, so here's what we've got message-wise so far. So we'll just refresh that. I wonder, maybe some of you you Linux geniuses, do you know if there's a way to watch, but to always have it start at the bottom of what gets printed out from the watch? That would be kind of cool. Anywho, so, okay, so we've got the halting advancement, observed deployment generation. I'm guessing that's just from the initialization. And then the initialization's done. So this is kind of where we're at from the describe event standpoint. So now let's go up here and see. Oh, nice, ABC. So I can just add the after command to grep, and then it will do that with the watch. That would make sense, actually. So let's see if I can do that real quick. So kubectl describe. Where was that command at? Kubectl describe. Okay, so if we run that through grep events A30, and then we watch on that, and then I think when it needs this complex, watch needs single quotes maybe. Oh, cool. Very cool. Nice. See? Learning something new every day from you all. Okay, so let's see if these things get generated. Cool pro tip. So if you don't have any If you don't have the event streaming kubectl command yet, you can just do what ABC recommended. It looks perfect. All right, so here we go. So we are going to do a kubectl set image. So here's the command, everyone, that we're going to run. And, by the looks of it, this is going to basically pull us through and set the image up. Let's see, Stefan, you can do a kubectl logs deploy flagger. Okay, cool. Yeah, good point, Stefan. Let's bring the logs up too for flagger. That'll probably give us even more interesting details. Oh, it'll print out the same events. I see. Okay, cool. So let's see if this goes through with the describe, and worst case, we'll print out the logs from there. All right, so you ready, everyone? See if it works? Here we go. So we will set the image. Image is updated. On our watch, we are updating. So we'll see what we get here. Okay, so new revision detected, scaling up pod test. Cool. And as Stefan said in chat, we can pump these same events into Slack, which is cool. Give us some increased anxiety in our Slack channels as our new app version is rolling out over time. All right, so I'm guessing at some point, based on the docs, we're going to eventually see the canary wait. So remember our canary deployment, right? It seemed like every 30 seconds or so, we should start bumping up based on whether this load test, I suppose, went okay. Okay, here we go. First step. So we've got the canary wait set to 5. Let's try some stuff up here too real quick, everyone. What do you say? So we'll do a quick curl while it's going, and let's curl against app.jkates.com. And was that all we needed? Okay, cool. So now if I bring this down, okay, so let's see if I do, okay, you can see version in the very top of my window here, right? So if I send some requests in, so far, and this kind of makes sense, I'm still hitting 3.1.0. Nope, I got a 3.1.1 right there. Okay, so clearly it's bringing a little bit of traffic in here over time, but then if I hit it again, you can see it's still over time hitting 3.1.0, 3.1.0, 3.1.0. We've pushed our canary wait to 10, okay? So what's this other one? Halt advancement, no values found for contour metric request. Podinfo.test is not receiving traffic. Success rate possible. So I wonder if that, Stefan, maybe means that maybe the traffic trigger is not kicking off to send traffic in, aside from my traffic, obviously, which I'm clearly sending in at some rate here. First, it runs the conformance test, then increase traffic, then metrics checks every 30 seconds. Cool. Okay. So far, I'm liking what I'm seeing. I don't know exactly how much traffic it's sending in via that load test utility, but it does seem to be slowly increasing me here, so that's good news. Oh, it's Prometheus scraping latency. Okay, I see. So just a normal, and I guess that kind of makes sense since it was just letting me know it's a warning there. Okay, cool. So it's sending that in, and all is going well. While we're waiting for this to go through, I think I saw something in the docs that shows how to force a failure. Let's see if I can find that again, because that would be a good thing for us to validate after this. Oh, there's a picture of what it could look like from the Slack standpoint too. Okay, so we've got that. That's what I was looking for. Okay, so exec into the load tester pod, and then we can generate 500 errors on the app, generate some latency. Okay, cool. So we should be able to hear everyone. So it seems like if I'm reading this correctly, we're sending the traffic in, it's slowly waiting us. It seems like as it's increasing that percentage, it's going through and actually, succeeding at the requests. Another thing we could check too, I'm thinking it would be reflected here. If we get the HTTP proxy for the namespace test, let's see what this has going on with it real quick. Test. YAML. Okay, so we've got this here and HTTP proxy, pod condition. Okay, so cool. Doesn't seem to be impacting anything here. So I wonder does it go into the HTTP proxy at all and change percentages there, or where is it changing the percentage of traffic shifting? Am I looking at that wrong? Let's see here. So we've got this pod info ingress. I'd expect there to be percentage changes. It's clearly doing it. I'm just not looking at the right way. Oh, right, Stefan, the other pod info. Right. Okay, let's see if I can get this before it gets too much farther. So this would be the pod info that Flagger owns here, right? So if we do an O YAML, there we go. Okay, so what Flagger's got going on here is it's adjusting the weight as time goes on between these two versions. So you can see, at least at this snapshot in time, it's going into this API that Contour respects, and it's moved us up to a weight of 40, and it's currently got the other one at 60. So as we all know, we should be pretty close here, because once we get 50-50, I think we should be in a place where it's actually going to shift completely over to the new version. So let's go back to our logs here. I'll just exit out of this buffer. Advanced weight, Canary is 25. Let me make sure I've got the right version of this. Advancing pods, 45, good. Let's see, you said ABC, the DNS hostname looked wrong. Let's look. So kubectl get HTTP proxy for the namespace test. So that's pod info. Okay, let's get that again. So pod info. Oh, I see what you mean. Yeah. Pod info canary dot service. I wonder if that might be, I wonder if that's a bug. Stefan says that one is not used and will be when linkerd will support. Oh, okay, cool. Hey, look, we're helping out. You're helping us out, Stefan. We're helping you out. So we found 2 dots. Good job, ABC. Good catch. So, yeah. So it looks like there's a weird value in there, but if I'm reading Stefan's message correctly, it probably won't impact us, at least for our use case with just Contour. Okay, cool. So what else do we got going on here, right? We've got the, just get the info here from kubectl, get out of the watch mode. 25, template spec to pod info primary test, advanced canary weight to 25. It seemed like the canary weight was more than 25 though, right? It seemed like it was at 40. So if we do get canary for the namespace, what are we in again? Test. Finalizing. Okay, so clearly we're closer. I wonder if I'm missing anything in the events. The weight going to 25 seems like we're farther than that. Seems like we are. Nonetheless, and I mean, I guess here's how we could check, right? If we just get the let's do a kubectl describe, because that's what Steve recommended, and I trust him here. So we'll do a describe HTTP proxy. Well, first we'll do a get HTTP proxy for the namespace test, pod info. So then we'll do a kubectl describe for pod info inside of test. And this will be an HTTP proxy resource, right? Okay, so what are we at here? I think we may have shifted over, actually. So what do we got? We've got the spec in here. Hostname. What are these? Date, target port. Oh, I'm scrolling the wrong way. Hang tight. That's why that looks so messed up. That's user error. Okay, so we've got the HTTP proxy, owner references, kind canary. Okay, so we can see the owner ref from Flagger here on the HTTP resource. So that's what Stefan was saying earlier. That again shows that this is owned more or less by Flagger. So Flagger's the one with its hands on the knobs there. And then we've got pod info primary. That seems pretty good, right? And yeah, there's our validation. So weight is 100. So in theory, we should be completely moved over. So maybe we deserve another another screenshot of our clapping cuddle. But before we do, let's just quickly make sure that we have app.jkates.com. Yep, looks like we've got exclusively 3.11, so that's awesome. And then if we do kubectl describe for, or actually let's just do get. We'll do kubectl get for canary. inside of the namespace test. Look at that. We succeeded, everyone. I think we deserve that. Good work. Okay, that's cool. So we saw some webhooks that we could put in, which seems like we could put in some arbitrary webhooks based on validation logic. So hopefully you're starting to kind of conceptualize how this could be pretty powerful, right? Like those webhooks are pluggable to whatever test load generating thing that you want to do. And then we have the validating logic going over time, stepping, and so on. Now, one thing I would love to do, I should probably do a quick time check. Okay. One thing I would love to do is I'd love to see if we can make it fail. That would be really cool to kind of see the rollback. What do you say? Let's give it a shot. Okay. So let's see what we got here. And it looks like per their docs, by the way, Flagger team, I feel like people don't compliment this enough, but good job with your documentation. It's pretty straightforward. I think there's a couple things like I got a little confused because some of the apply commands were pointing at like, where was it at? Oh geez, now we're pointing at like a GitHub, which I think kind of assumes you have the repo cloned and something. But aside from that, these docs have been really, really great. Good work. Anywho, so HTTP 500 errors. Okay, so we're going to exec into load tester, it looks like, and we're going to run a command which is going to do status 500. Seems good. Okay, let's just see what happens. So first things first, let's exec in. Cool. So we're in. And if we run this command, it should generate 500s. Now, the question is, does it want me to run another update? I would think so. Oh yeah, it's got another update in here too. Okay, I see it. So we're gonna set this up. So first thing we'll do is trigger this deployment. All right, so let's get some windows set up here. So just like last time, we can kind of check this out. All right, so this will be the command we run. So we're gonna bump ourselves up from 311 to 312, which makes sense. We are inside of the load tester utility. So I'm guessing if I'm reading their docs right, we're going to trigger the update. We're then going to run this command inside of load tester. So that's going to be this command, which is, if I correct this, it looks like this should, app.jkates.com. This should start causing 500s to happen. And I'm not super sure how all that works because I'm not super sure how load tester works, but I'm going to take their word for it that this should generate some failures, because that's the most important thing, is that our canary gets failures back. And then it also has a recommendation to generate some latency as well. Okay, so let's just check this out. So when the number of failed checks reaches the canary analysis threshold, the traffic is routed back to the primary. The canary is scaled to 0 and the rollback is marked as failed. So this is what we want to see, everybody. If we check out the logs for Flagger, okay, and this is what you were saying earlier, Stefan. So if we tail these out, and we'll tail them out instead of looking at the events, we should see it increase, it increase, it increase. I'm going to flip the switch to start causing errors. And then if all goes well and I'm reading this right, we should start seeing some type of rollback. So let's see if we can get this to work, okay? So this will... Okay, so first things first, let's do this. Let's send this in. All right, so we've just done an update, everyone. So let's check this out here now. Okay, this will be the key. We will start watching logs. Okay. And hopefully it will say new revision. There it is. New revision detected. Okay, everyone. So we've got new revision. That's good. New revision. Now, I'm not sure if the docs just want me to run this right away or if I can run it after a couple seconds. Maybe, Stefan, you can jump in if I'm doing this wrong. But I'm hoping, I want to see it scale up, like to canary weight 5, maybe canary weight 10. And then I'm hoping I could run this command so it kind of gets partially into the rollout, if I'm thinking this through correctly, and then it should start failing on us. Okay, so we've bumped up to 5. That's good. So we're basically doing the same thing with Flagger now. We are headed up to weight 5. Hey, Stefan, my domain is accessible inside the cluster. It's using a public DNS record, which is then returning a private IP address. So as long as that'll work, I'm pretty sure that should be okay. Cool. So that seems good. This is good. All right, also, Okay, it's got to 10. Let's now hit it with some 500. So I'm going to run this command, which hopefully, I don't know if that stall there is a good thing or not. Maybe it's got something to do with my domain causing issues. Like I said, this is returning a private IP address, but the private IP address it returns should be accessible to whatever this is. I don't know if this normally gives output. The command will generate 500 for... Oh, hey, it worked. Check it out, everyone. So we are currently seeing some success rate errors. That's good. That's good. So let's try to calculate this. So we're at 10 right now. Success rate is 48.3%. Is this saying 48.3% for the P99? I'm guessing that's the case. So our success dropped below 48.31. That's good. And to Stefan's point, okay, so we're still getting errors. Okay, good. So now we stopped. So this will be interesting, everyone, right? Now the 500s have stopped. The question is going to be, will it start picking up here and kind of realizing, okay, things seem healthy again. Let me go ahead and bump up again. And if it does, then we'll just go ahead and put a bunch of error messages in, more 500s and increase the latency. And then hopefully we can actually cause it to roll back if all goes bad. But I kind of want to see it go through both modes. So, okay, so it seems like we're still in a halt mode. We haven't rolled back because we haven't triggered that condition yet based on the amount of failures. But we can see our percentages slowly going down. And I'm guessing by the next time it triggers, we might be below where it needs to be to continue. So let's see if that happens here. All right. Yeah, this is pretty cool. What do you all think, chat? It looks pretty good. It looks pretty good. Success rate. Oh, that's the success rate I'm looking at. Okay, that makes more sense. So my success rate is climbing now. We're at about 93.22%. Looking good. All right. And then I'm thinking in another 30 seconds, we should kind of pick up here and be good. Let's see if that works out okay. I guess I should have lowered my time below 30 seconds. Okay, there we go. So we're healthy again. So we had this, that's a perfect example of these Canary rollouts, right? We kind of went forward and then we started hitting 500s. We got below our threshold, which was set in the Canary object, right? And it looks like we halted. We eventually got back to a healthy enough state. And now we're going forward with more deployment traffic. So let's really make it upset now, okay? So what we'll do is let's just run this again. And I'll keep running it over time. Cool. So once the number of failed checks reaches the Canary analysis threshold, supposedly we should be good. So let's just keep an eye on this as we go. And since we're getting a little bit closer to time here, I just want to make sure we can knock out one more quick thing before we call it. So we'll keep this in the background and take a look in a moment. So, all right, so rolling out seems to be working pretty well. The last thing I wanted to check with you all was a little bit around A/B testing inside of here, because I know this is a really common one where we're not just releasing kind of a new version, but actually going through and like based on headers and stuff, determining which version to show to the user that's calling. So it looks like inside of our Canary analysis, all we'll have to do is change the conditions, the match particularly. So we should be able to go in here and change some of the headers. Keep that going. What's it upset about? HTTP. Oh, I did the app example again. Josh, come on. app.jkates. We'll see if this is gonna hang us up. Yeah, you're right. I had the wrong domain there. All right, let's see if that goes through. All right, maybe we'll make it fail. And then ideally, I think, so there's two things I want to see with you all. I want to see if we can get an A/B test done real quick. And I also want to see if we could see this rollback. Because what we didn't get to here just yet, because I was too excited about seeing it halt and then go again, is once it fails for the amount of duration we've set, we should eventually get something like this that's like, hey, bad things are happening. They've been happening for too long. I'm going to start rolling back, right? So let's see if we can get that triggered inside of here. Cool. And then we'll get to our A/B testing as well. Yeah, this is very cool. Okay. All right, there we go. So we've got it. Canary failed, scaling down podinfo.test. So rolling back checked. This is our failed threshold. So we'll check our Canary one more time to validate this, but it looks like based on the 5 that we've now hit, we are going backwards, and it should bring us back to, I believe, our original amount. So while that's going, let's check it out. So if we do a kubectl get canary, inside of the right namespace, of course. Perfect. Okay, so we see, I mean, not perfect if this was a real thing, but perfect in our case. Pod info has failed, so we should be back on purely version 1. So if we check that out from a contour perspective, we'll do kubectl get the HTTP proxy for pod info in the namespace of test. Good. And then we'll do the YAML version, and then we'll do less. All right, so now you can see we have wait 100 pointed to this particular pod info, which is good. And then that means that if we were to curl this app, yep, there we are. So we're rolled back to 311. Awesome. Very cool, everyone. So we successfully shifted traffic, induced an error based on the load testing tool, which again, I'm not super familiar with what the load testing tool does, but it seems pretty clear. We triggered a bunch of 500 responses, and then it completely rolled back to its original versions. That is pretty darn cool. Very awesome. Does that make sense, chat? Does anyone have any questions on that? It seems pretty straightforward. I'm really excited about it. So let's do one more thing before we end it here. Let's see if we can do like an A/B test just to show a change in some of these canary settings real quick. What do you say? So A/B testing, for those of you who might not be as familiar, is in most cases something where you've got 2 versions, and then based on some type of criteria, you go out and it will send you to the right version based on some header or other criteria. Again, I mentioned it earlier, but a super common use case is like, I want to roll this thing out, this UI change to EMEA and not the US. And based on results, I want to determine whether it's something I want to roll out in a larger scope or whatever it might be, right? So overall, it looks like we're mostly just changing our canary analysis. So let's see if we can do that now. So we will back up and we will get back into c.yaml, which is where we've got canary in. Let's find the analysis here, which is right here, okay? All right, so actually here's some of the things we were just looking at, right? So threshold 5 seems to be what we hit. We went up, we failed enough times. Once we failed 5 times, we triggered a rollback. There's our 30-second interval, which I'm sorry, everybody, you had to just stare at me for each one of those 30-second blocks. And then there's our max weight that we were setting before. Now, it seems like in this case, it is going to want to do this based on a header. So I'm going to copy this out of their docs and see if we can sort of put it in here. So we've got that, we've got interval. Okay, so I think somewhere like here, we should be set to add in match. Just fix the spacing real quick here. Okay, canary, that should go in twice then too. Okay, so match headers canary exact insider. Okay. So it looks like as long as we've got that header going in for exact insider, we should be able to see a specific version. So what I'm trying to figure out is if we set a new image, I'm curious what's going to happen as far as routing goes. So let's see here. So if we look at where's the update command? Okay, so trigger a canary deployment by updating the container image. So we go to 313. That makes sense. We're going to bump ourselves to 313. And then I would think we'd have 3.1 and 3.13 running side by side. Now, Flagger detects a deployment revision changed and starts the A/B test. Okay, so canary iteration, iteration, iteration. So this is the 30-second intervals, I'm guessing. I guess we'll see. So waiting for rollout to finish. So this is just like a timed A/B test, if I'm thinking of this correctly. So my hope would be if we run this, if we run curl and we add in the header for X canary, Okay, and then I'm guessing this is just a qualifier, so you can probably do like fuzzy qualification and stuff. So if we do a header for X Canary and the value is insider, I think we should see 3.1.3. That's where my brain has gotten me so far. So let's see if that's actually right. Okay. So let's see what else we got going on in chat before I try that. May reduce. Okay. A/B testing, specific client. Client will always see A, others. Waleed, you said in A/B testing, can you specify by client, like a specific client always sees A, others see B? I would think you'd be able to do that, Waleed. I'm not sure how advanced it is. Stefan could probably help us out here, but I'm thinking in this case, only clients that satisfy this match are probably going to get my new version. I don't know if you're looking for a qualifier as well for the old version, like having a match for going to old, or maybe even running an ABC test, right? But I would think you could probably use any arbitrary header, like ABC said with user agent. Like, I don't see why you couldn't use user agent, and then based on the user agent route to a certain pod. It seems like as long as your match functionality here was set, it seems like it would work fine, honestly. Cool. So let's see. You were asking if you can use Flagger with traffic. I have not heard of traffic support, but Stefan can probably let you know if that's at all something they're thinking about. Lead and maybe reduced by 30-second interval. Okay, cool. And then Stefan, I'm not sure I'm tracking your suggestion on you forgot to change the interval. Do I need to change the interval for Canary? Well, I guess, yeah, the interval 30 seconds would be way too short, right? Are you suggesting that I like bump this up to like 5 minutes or something? Is that more or less what you're saying? Probably would make sense. So, okay. So theoretically we'd be open for a 5-minute interval with Canary analysis. Seems good. And then Stefan said, yeah, so my match logic is as advanced as Contour's HTTP proxy filters. Okay, great point. So let's see if it works here. So no op change the min max to iterations. I'm not sure I follow you there, Stefan. I'm guessing I'm doing something wrong. No operation change the min max to iterations. I wonder if I'm missing anything in the guide here. So we've got the headers, cookie, insider. I don't see anything crazy here, everyone. So it seems like webhooks, insider. Oh, that's just a cookie example. We're doing this one. So interval is 1 minute, threshold's 5, iterations is 10. Do I set iterations before, given the other? I guess I wouldn't, right? Yeah, so iterations of... So I'm having a hard time wrapping my head around all of the API just because it's new to me. But I'm guessing iterations would be, if I put a 10 here, I would run this AB for 10 iterations of 5 minutes. Let me know if that logic is correct. So I'm thinking this means 10 iterations of 5 minutes where the A/B test is live. So now we just got to see, can we match this thing in Contour as far as Contour's API is concerned? So we'll put Flagger and Contour to the test here as our grand finale, everyone. What do you say? Okay, so remember our header is X Canary. I'll try not to forget that. And then exact match for insider. Good deal. All right, so first things first. Does this blow up on us? CYAML, and I probably should run a command with kubectl. What do y'all say? Seems like it'd be pretty helpful. Okay, so now we've configured the pod info. And we should be good. Now, isn't that long for us now for 5 minutes? That's a good point, Waleed. If we're gonna see the iterations happen, you might not want to wait 5 minutes per iteration. It seems like I might be making that a little too long. I agree with you. Let's drop it down to 30 seconds. I think that seems pretty solid, right? Yeah, pretty good. Okay. Stefan agrees. Okay. Y'all don't just want to sit here for 5-minute intervals in between each one? I mean, that seems totally reasonable to me. Okay, so we've got that set up. I think we're good. Oh, the load test, right. So, yeah, should I change the load test? I guess I should if I'm going to qualify this. Because I was thinking like, oh, we just use curl and test it, which is totally fine. We should still do this. But I probably should change the load test too, right? So inside of the load test, for my application, which is right here, I'm going to add a header, and in their docs, they've actually got a snippet of that for me. So I'll steal that to save us some time here. What do you say? So right before host, not that it would matter, I'm going to put in X Canary Insider. So I will be passing in this test here. Okay, just looking it over one more time in chat. If you see any mistakes, let me know. But I think overall this looks good. So all should be well. Okay, let's save it up. And let's see what happens now. So we'll apply this one more time to get it configured. Okay, we'll do a kubectl. Okay, actually, we'll keep it as is for now. So let's see what we can get running here. So first things first, let's run the logs. So, oh, I copy and pasted out of maybe some other guide. I don't know if that may have gotten copied weird. So namespace test. Where's my logs command from before? Project contour is where I had it. Yeah, so I think very, very minor, Stefan, but for your docs, I think in the A/B testing section, I think you've got an example that probably got pulled from the app mesh, thing, but that's no big deal. Okay, so we're logging. So HTTP proxy updated, synced test info. All right, I think we're okay. So let's run an update and see what happens. What do y'all say? So we'll paste it in. All right, we have just updated. So let's wait in the bottom here and see if the update is realized by Flagger. All right, so it's seen. That's a good thing. We're so close, everybody. Let's see if we can make this work. Okay, so once it starts its thing, I would think now it's probably in A/B mode. So rather than seeing percentages go up, I think we should just see iterations ping every 30 seconds. And I'll start messing with curl up here while we're waiting too. So I think if did I mess this up? Did I change the host name? I bet I didn't change the host name, did I? No, I did. It's good. Okay. I didn't change. Oh, I never messed with that. I just put the host in, right? So if we run curl one more time, let's see here. So curl this, and then the flag for curl for header, I think is just -H. So I'll paste that in from before. All right. Okay. So we're at one iteration. Okay. So seems good. So now we'll curl the insider, and hey, check it out, everyone. Pretty sweet. So if all goes well now, hopefully I don't get excited over nothing. If we pull the header for insider out, we should now be at 311, right? Because remember, the old rollback failed. So if we now go back, fingers crossed, everyone, we got this. We're just going to take the header out, and we will, let's just do this for version. No URL specified. What the heck did I just do? The output grep for version. Oh, I'm doing something stupid. Okay. Oh, there's the H flag still there. That's why. My bad. Here. So let's do this for version. Actually, last TGIK that I did, or a couple of ones ago, someone told me I should be using rest in peace grep because that's the new cool stuff, right? All right. There we go. Check it out. So we've got 311. And when we add in the header again and do another RG and do version, we get 313. Pretty sweet, everyone. Check it out. So we're going through our iterations over time. Really, really cool. That's sweet I mean, obviously we deserve this now, right? So we've got our Canary iterations going. I'm guessing if B started getting some failures, remember we're still using the webhook, so we're still triggering the load test. So if B started getting failures, the A clients wouldn't be affected in the first place, or the clients without the header, and then B would start failing. And I'm thinking that during these iterations, if we get over our threshold of failures, similar to last time, we would then roll back. And I'm guessing rollback in this case would simply mean that we would just go back to the first one exclusively, regardless of your headers. So that is super, super cool. I say the last thing we check out here, everyone, and then we'll just high level everything and call it a day. Let's do a quick kubectl get get HTTP proxy for the namespace test. This was pod info, and we'll do an OYAML out to less. All right, so what do we got set up here, everyone? So check it out. We have got the, oh no, those are the request headers from before. Where is my request header logic at? Pod info. I'm looking for insider in here. I guess insider should be written. Huh, it doesn't say anything about insider. Am I messing? Oh, there it is. I don't know what I did there. Anywho, so here's the condition it added to the spec. So again, this is what's super cool about, Flagger being in your workflow, is that it's plugging into, whatever APIs that it's aware of and has plugins for. I don't know if it uses a plugin model or what the deal is, but nonetheless, it sits in the cluster and it's like, hey, I can talk to Istio, I can talk to Glue, I can talk to Contour. Just declaratively tell me what your rollout strategy is, and I'll turn the knobs because I understand the API, and I'll make it happen. Which, as we all as a group get deeper into like the GitOps realm, and we start doing more stuff with like, Argo Flux or whatever those projects are in the grand scheme of things. I know there's like been talk about some GitOps projects merging and whatnot. But nonetheless, as we get more into the conceptual GitOps model, I think things like this, be it Flagger or otherwise, although it looks like Flagger's off to a great start, are just going to be super, super critical in making sure that app teams feel comfortable with making a change, having it slowly roll out. And how cool is it that it's fully automated, has rollback mechanisms and all that good stuff. This is some really, really neat stuff. So to kind of end it here, I just want to look in chat and make sure we've gotten all questions answered. So drop the H. Yep, you guys got it. You all got it. Maddie, how do you automatically add that header to a small percent? That's a good question, Maddie. So Stefan, if you're still on, I know we've been here for a long time. Could we get as specific as saying, hey, go ahead and do it for the insider header, but only on this percentage of traffic on top of that? In other words, can we kind of like embed Canary analysis conditions to some degree? Is that something that's able to be done today or being thought about? That would be super, super interesting. So very cool. So those of you who dig a little bit deeper into Flagger, I obviously didn't exhaustively cover everything it can do. And some of you might be using different service routing. So if you're using Nginx, AppMesh, Istio, be sure to check that out. It's obviously going to be capable to work with a lot of your different things. Some other things that I just want to mention as well and call out to the project, since I didn't explicitly try it today, is that it also supports, where is it at? I'm looking for the blue-green mention. Oh, there it is. Okay. So it also supports blue-green traffic switching, which I did not show you all today. So just be aware that that's there. And let's see if there's anything else I wanted to mention. I think that just about does it. So unless anyone has a question in chat, hang out for another moment here. Once again, we got it, everyone. We made it happen. So we tried out Canary deployments, shifting traffic over. We failed a Canary deployment and got to see it roll backwards. We did this all with Contour 1.2, by the way, which wasn't tested at all. So thank goodness that worked. And we even saw an A/B test where we were able to, based on a header, send traffic to a certain version of the application. So again, kind of the call to action. I'm hoping that those of you who are playing around with GitOps have kind of been inspired by some of this tool set. I know I am. I'm really excited to play with this more and see how I can help my customers build out, more automated, safer, really, pipelines for their deployments. So, all right, everyone. Thanks so much. Chat, thanks for hanging out and finding my typos and answering questions. Stefan, if anyone's still in chat, please be sure to thank Stefan from the Weaveworks project, who spent a big chunk of his afternoon or evening here helping us out and answering questions. We super appreciate it, Stefan. Keep up the awesome work with Flagger. And I guess you'll be seeing Joe, Duffy, or myself next week. So we'll see you all then. Have an awesome Friday and an awesome weekend, everyone. Thanks again. Bye.